Hello.
Hello. Thank you for coming. Okay, so this is Chris Pitts.
Hi.
I'm Ron Ballard. And if you heard the 20-second introduction, we've been very interested in combining Agile development with the database stuff, which is usually separate. But I should. Do you want to do that?
Yeah, if you just hit a button, it will go forward.
So, even in Agile projects, which is, everyone claims to be doing Agile, some people are, and we've worked in some pretty big and some small companies, but it's usual that the database design is done with a waterfall methodology. I don't know if it's because of this, but all the classic textbooks, the things that are all recommended on the university courses are this thick, 1,200, 1,500, 1,600 pages, cost you 70 quid or 120 or something. And they start off with conceptual modelling, logical modelling, physical modelling, and then sometimes presentation layers, others as well. And the implication is always that you do all that stuff up front. And then once it's designed, it's frozen, and the developers have to live with it. But we can do much better than that, and we have been doing it for a long time. I've been working with databases for 40 years, and since 2003, after meeting the friend who introduced us, who's a real great Agile guy, we've been doing it more and more as Agile projects. So the last big company I worked for was a big payment company doing 1 billion transactions a month. And they were redeveloping their payment processing, which was 27 years old and running on COBOL on a mainframe. So they started off with conceptual modelling and logical modelling, and they claim, this is their claim, not mine, is they claim they spent £400 million doing this. They had a whole team of designers with great big workstations and really expensive design software, and they spent 4 years messing about with models. When they finished, the developers came along and said, we can't use this. They threw it away. £400 million. They did have some diagrams, though, and they had an A0 printer and one that would take a roll of paper, so you could make wallpaper like that. Right, we're going to jump into, trying to compress this into 90 minutes. It's quite short. So we're going to jump into one of the first things that we do in designing a database as we go along. We'll come back to the actual Agile process a bit more, but we want to give you something to get started with on the first exercise. So the first thing you do is make sure that all the fields in the database, every cell in the database, every column, row, intersection, is one field, one elementary object. And so this is a line from an XML file that I was given from a source system. And can you read what's in there? There are 3 things in that XML element. The manufacturer of the car, this was for a car insurance system, the model of the car, and the registration number. So if you get that into your system, and you've then got to process those things separately, how are you going to parse that? Well, you can look at that one, and you can probably work out how you could write some substringing functions that would pull that apart. But then the next one you look at is like that. So if you said, okay, the make is everything before the first space, not if it's Land Rover, it isn't. And if you say the registration number is everything after the last space, well, with that one it isn't either. So it got very messy to handle that. And we ended up with lots of lookup tables and trying to keep the manufacturers up to date and the car models up to date was really expensive, whereas what they should have done is that. That's nothing to do with databases, that's just designing an XML file properly, putting the separate things in separate elements. But it certainly does apply to databases too. So the way we've been doing it is when we're building a new application, we're going to start with either start with empty tables in our database and the application populates those, collecting stuff off web forms or off some device, Internet of Things device. and the database will gradually get data in there and populate itself. Or we're going to be migrating data from an existing system. I'm doing one at the moment with a customer management system where they've got to capture all the stuff that's in the old system. And so we're starting off with migrating that data. Usually it's both. Usually there's some data that already exists, or there's some reference data or master data, and there's some you're going to be collecting new from the new application. So for our exercises, to make it simple so we don't have to write an application to collect data, we're starting from a spreadsheet, which is a very common starting place. And we're going to use iterative development of the database wherever we get our data from, and we'll explain more about how that works in just a minute. But I think we're now ready to hand over to Chris.
Excellent. So, we weren't quite expecting this sort of layout, but we're going to work with what we've got. This is an interactive session. You will need a laptop, or you will need to pair up with somebody with a laptop. The example we're running, we're essentially using Java, because it's easy, Gradle, and we're going to use Postgres in Docker, just to save people installing Postgres when maybe they wouldn't have it on their machines. Who's got a laptop with that stack on it? Fantastic. So if you could pair up with somebody who either has a laptop and has that already, or can install that, that'll be fantastic. Nobody moves. So find somebody where you can see a laptop with that stack, and if you can clone this repository, it will make life a huge amount easier. Because what we'll do is we're going to give you a chance to actually do the migrations. And then you can see how we've done it. So the first experiment is self-organization, is find yourself either visibility of a laptop or a laptop with this stuff on it. Like I said, this layout was I was rather hoping for tables, but never mind.
I think we're going to have enough. You're going to demo it anyway. Yeah.
Was it something we said?
Oh dear. You can just stay and listen to the rest of it. Most of it will be taught.
Once you've actually got everything installed and cloned, can you just put your hand up, please? Just so I can see roughly
Excellent.
How we're doing. First rule of running a workshop. Never assume what you think is a common stack to be a common stack. So has everybody managed to clone the repo? Yeah? Cool. Okay, let's get on to some fun stuff. Now, in the repository, right at the top level, there's a directory called scripts, and there's a script called start postgres.shell. Basically, all that's doing is just firing up a Dockerized Postgres. It'll download it, and it will just come up with the right config that we need for this exercise. So give it a go. Apologies to the Windows users, by the way. Yes, of course. Yeah. Git bash is probably your best bet. Like I said, apologies to the Windows users, but if you just use git bash, everything should just work. Okay. Disclaimer, I haven't actually tried this at home.
Not on Windows, you've tried it on Mac.
That's right, yeah. It'll just download the current one. It's using latest. So that's absolutely fine. I'm assuming they haven't made a breaking change in the last 24 hours. Can we move on yet? Is everybody? I'll come and give you a hand once we kick off everybody else. So once you've got Postgres started, let's tell the story. What we have, you've been contacted by a yacht club. And they have an Excel spreadsheet. And I'm on the wrong screen.
For their membership.
Bear with me while I learn how to use the system. This is just in the README. So basically what's happened here is you've been contacted by the local yacht club who has an Excel spreadsheet of their members, their boats and their qualifications, and when they joined, and all sorts of good stuff in there. If you look under the directory in iteration 0, original files, you can see you've got the files that you've been given. So what we are going to do now, over the next sort of 20 minutes or so, we're going to start to get a feel for how we can actually migrate the database. What we're going to do is, we've given you the CSV. This isn't a test of can you drive Excel. We wouldn't do that to you. We're not that evil. But what we're going to do is we're going to create, under DB migration, under iteration 0, a script that is going to create an initial database structure, initial database table that is going to hold the Excel data. And we're going to pull in the CSV in a second script that's going to take the CSV data and plonk it into that table, unceremoniously, warts and all, because if you look carefully, what Ron was saying about composite fields is exactly what you have in that Excel database. The boat data is all munged into single cells. The qualification data is all munged into a single cell. And the next step, you can guess what it's going to be, we're going to pull it apart. We'll talk about that later. What we do have, just so that you know how this is working, is we're just going to be using Flyway. And I'm on the wrong screen again. Flyway is one of many, many frameworks we can use here. It's a Java one. I think it's a particularly nice one. One of the more recent ones, you've also got the likes of Liquibase, DB Unit. Who's heard of DB Unit? It's been around forever. Loads of them. And basically, all that's going to do is it loads in database URL, username and password, which is already defined for you. You don't have to worry about this stuff. It goes to DB migrations and says, what's been run? And it goes through them, ding, 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 ding. And it will ignore anything that's already been run. And once we've swept through this iteration 0, we'll show you what's happening inside the database. We'll show you how to look inside the database and see what's going on. We'll explain what's happening. So do you think you can do that? We are not, as I said, that evil. We have given you crib sheets. So you might, I don't know, you might want to look at these files and see if they give you the clues you need so you don't have to write all this SQL. So if you go to the README, should give you some fairly heavy hints about where you need to go with this stuff. And what we'll do, we'll go around and make sure everyone's doing all right. So, hint, Sailing Club Excel.SQL for the first one. And so on and so on and so on. And what we'll do is we'll actually build up the database. Is that fairly clear? I thought there was a question coming. Give it a go. I'll be coming round to lend a hand where I can. I'll just put the slide back up so you've got the details. I'll work out where my cursor's gone. Right, we need to push on a little bit because we thought something like this might happen, but we have one we prepared earlier. So,
you're going to run yours?
Yeah, I'll go through this.
Okay.
So basically, what the steps we were going through now, we're doing. Left-hand one, the Sailing Club Excel, is a straight copy of our Excel database, and we're just mapping it to Sailing Club first. First, because that is first normal form. If you use normal forms, your database understands pretty much what you're doing and will, I'm not going to say optimize itself, but can start to second guess what you're trying to do with the relations inside. Now, someone came up with a fantastic question. What about the frameworks that do this for you? What about the frameworks in .NET, Hibernate and Java world will actually design your database for you based on your classes, and your developers write classes and they magically get mapped to the database? Fantastic question, fantastic point. I'm going to say that these frameworks are not always very good at generating something that's efficient. There will still always be a little bit of database design involved. I'm going to pass over to Ron to go through some of the things around that. I think that's a little bit later on. But these normal forms are actually essential for good database operations, and these frameworks don't tend to map to them very well. So that's why we're actually going through this exercise to show you how objects map onto tables.
Right.
I'll hand over.
So, it's supposed to be, can you hear me all right? Yeah, let's move on. So, what I wanted to do was just get something that would work, first of all, and then explain a bit more about what we're doing. So, the idea of iterative database development is that we're still using all the disciplines of database development. We don't necessarily have to use all the jargon, but we do it a step at a time rather than designing the whole thing up front. I mean, it's just the same as you do with application design. You don't anymore design the whole thing up front. You design a bit of the database that you need for this iteration, and for the next one, you migrate it to what you need next. And that is pretty straightforward, not if you're trying to get the whole environment set up with different people at once, but anyway. So, and the data model, the actual tables and the relationships between them should be a direct model of the real objects being processed by the application, the real objects in the organization that you're building the database for. The users should be able to look at the table names and understand what it is that's in there. Very often what you see in traditionally designed databases is they just wouldn't have a clue. It's just hiding it from them. But there's no need to do that. There's no need to have a different conceptual, logical, and physical model. The physical model is the real one, and that should be as much like the real world as you can make it. And then if you understand the data model in the organization, because they won't talk about a data model, but they will know that well, in the sailing club terms, that they've got members, and the members have got boats, and the members have got qualifications, and so you can let this guy drive the safety boat, but you can't let that guy drive the safety boat, that kind of thing. And they will know what those things are, and they will know how they relate together. So the database, really, when you understand what they want, the design of the database is very simple. It shouldn't be this ivory tower thing. You'll find in a lot of package software that they've got what's called an abstract data model, which is just another layer of modeling in between the database and the real world, which is horribly inefficient. So to try and get this, all the jargon and the ideas of database modeling, the ones that you need, we've come up with a checklist, which is what I use in projects that I'm working on with the users. So the first one we looked at, there's every column being atomic. And the reason for that is that once you've got it into that state, then it's much easier to write the queries. You don't have to write statements to unpick it every time. You do it once right at the beginning. And you'll see how this model develops into something that's easier to use as we go through. Every row has a primary key. If you've got two rows that are the same, what does that mean in the database? If they're exactly the same, why would you have two of them? You need some way to distinguish between them, even if you've got two people with the same name, for example, or two transactions on the same date for the same amount of money. You need to know that they're two distinct things. So primary key is just normally a number, an integer, that identifies every record separately. And normally, I end up using surrogate keys, so you get the database to generate a serial number as it adds the rows to the database. A recent innovation is a bit more clever than that. It's called an identity, and it will be clever about what's already in the database rather than just picking the next number. The next one, every column in a row depends on the primary key and nothing else. Well, I think if you're, how many of you would call yourselves object-oriented developers? Do you use object-oriented languages? Okay, that's pretty much everybody. So in an object in your application, all the properties should belong to that object. So for example, if I'm modeled in the database as a person, I've got first name, last name, date of birth, national insurance number, and if you put the size of the engine of my car in there next to me, well, that would be right. But what if I had no car or 3 cars? That engine size doesn't belong to me, it belongs to the car, and then there'll be a relationship between me and the car. So that idea of keeping an object with its own properties and nothing else is exactly the same as keeping a table where all the attributes depend on the primary key. That's another way of saying the same thing. They belong in that table. No repeating groups. We'll come back to that in a minute. And then there's some other, so that's those first few. Oh, no, I'll come back to that. There's some other things that I like to do, and that's to have strong data types. If you store everything as a string, then you'll have no trouble loading the data because it'll always load, but people will load things that aren't what it's supposed to be. So you'll get things that aren't dates in a date column and that aren't telephone numbers in a telephone number column and all those kind of things. And particularly if it's a numeric value that you're going to want to do some arithmetic on or sum it or average it or whatever, you want to know it's a number. You don't want to be checking every time you do it. So if you store it in a field with a number data type, then it won't let you store something that isn't a number. So I always use strong data types wherever possible. Another thing is you get some bizarre naming. Well, you get some bizarre naming in applications as well, but you certainly do in databases. People come up with these enormous, complicated prefixes. Does anyone work on the Microsoft stuff when they were talking about Hungarian notation? That got completely out of hand. I don't think many people do that in it, but people in databases do insist on putting ridiculous prefixes on, like tab underscore for a table name. Well, you know it's a table. The database knows it's a table. So the names should describe the things that they're representing. Restricting nulls. you can tell the database whether a field can be empty or not. And if you've got a field that genuinely can't be empty for the database to make any sense, then the database will check it on the way in, so you can't get bad data in there and you don't have to deal with it afterwards. Same kind of thing with constraints. You can say all kinds of constraints about the relationships between tables, and that means that you can avoid ever having broken links, because again, it will check on the way in. So that reduces database design to a pretty short checklist. You need to know what's behind these little four-word statements, but it's not too difficult to learn, and it's fairly intuitive, I think. So those of you who've heard of database normalization will spot that the first 4 of those things were things in the checklist about database normalization. It's useful because it makes your database easier to use. As we'll see, well, we've seen already with the list of qualifications. And if you want to search that, you've got to, as a comma-separated list, you've got to go through and pick out each one and test it separately. If you've got the qualification there once, then it's much easier to run queries on it, and that's one thing that normalization is about. The other thing that it's about is if you're running a transaction processing system rather than, say, a data warehouse, then normalization really helps to protect you against duplicate updates and various kinds of mistakes that you could make when inserting and updating data to the database. So that's what normalization is about. It comes with a lot of obscure jargon, but really you can sum it up in those things in the checklist. Also, any Ruby on Rails people here? No? Okay. Ruby on Rails has another way of describing relationships, for example. Has one, has many, has and belongs to many. And that's basically all the kinds of relationships you need. And that's in the constraints that I talked about on links. So we've seen one example of normalization in the first exercise. And hopefully you'll agree that that's useful. Those first 3 are the main ones. There are lots of others. I think what happened was after the guys, Ted Codd and aided and abetted by Chris Date, came up with the first set of normalization, the first set of rules that would say this makes a database that's easy to update. People went off and wanted to do PhDs and found other obscure cases where they could talk about a way of transforming the data into a safe, updatable structure. So you get these really unusual things. I've never seen them anywhere except in textbooks. So for the most part, you can ignore those. If anyone finds a case like that and you think it's important and you think I ought to have thought about it, then by all means take a card and send me an email, because I'll update my book.
Yes, I should
really, I haven't seen any great use for this.
I should add, I was tortured with Bryce Codd when I was working as a very young developer in British Telecom. I never did understand it.
Well, another thing that's about is overlapping candidate keys. If you use surrogate keys, which they're the standard in Ruby on Rails, and I tend to use them for everything now, then you don't get that issue at all, because you've already worked out what the complications of overlapping candidate keys are. Yeah. Anyway, so this is the second exercise, and we're taking. So what we did in the first one was to split out the qualifications, and the boat is one column in the spreadsheet, and it's got the boat class. Anyone sail dinghies? No? Okay, it means a lot to me, but wouldn't you? And so there's a class of boat, and that means these boats can all race against one another, and they'll be pretty much the same. No one will have a particular competitive advantage over any other one unless they've spent a lot more on their sails or something. But, and then there's a sail number which identifies each boat in that class as a registered boat of that class. And there's a racing handicap, which is charmingly known as the Portsmouth yardstick, which means that I'm sailing a little boat called a Wanderer, which by the name you might guess is pretty slow. And there's someone sailing a Fireball, which you might guess by the name is pretty fast. And we can race together, and then we can look at our times and apply this handicap and say that actually I beat the Fireball, which I love. Anyway, but the point is that there's groups there of 3 attributes together, and then a repeating group there. So the first thing we do is to migrate the member out into a separate table with only the things that belong to the member in it, that are direct properties or attributes of that member. And then we have a qualification table, and then a relationship between members and qualifications. So the list I got was from the Royal Yachting Association. They do dozens and dozens of possible qualifications, and people do work their way through those for the particular kinds of boats they want to sail. So there's a distinct list of qualifications. There's a distinct list of members. A particular member might have no qualifications or 5. The qualifications and the members exist in their own right. The relationships between them just says which members have got which qualifications, and that's how we model that. That's the has and belongs to many. So there's a table in the middle which says this is a relationship between a member and a qualification. And that makes it very easy to query, as we can show at the end.
Yeah, can I just add, can you see the objects appearing here? It's basically mapping from the objects into the table and becoming much more coherent now. So you've got the member object, you've got the qualification object. And then you've got a one-to-many and a one-to-many. So a qualification can be held by many members. A member can have multiple qualifications. And this is what it looks like under the bonnet in the database.
So should we leave the exercises to the end now and just carry on with the next bit?
What do people want to do? Do you want to carry on with the exercises? Or do you want to take the exercises away and we'll just run through the slides about the different stages?
Carry on.
Okay. We'll just carry on.
That was a move on, was it? Okay.
I'll brief you on the different stages of the exercise right at the end.
Yeah. So then we'll know how much time we've got left and we can do that. So how we make our database development iterative rather than having this great big expensive process of doing designs that don't get used is that we design only what is needed for the iteration, for the particular sprint that we're doing. And that should be really familiar from the application development side as well. That's exactly what you do. You don't build stuff that you haven't agreed to build as part of each iteration. And the first migration, which quite a few of you did manage to do, was to create the first table, which is good. So that's normally what the first migration is, and then the developers can start using that and populating that table and using it for whatever they're showing to the users. Very often, in a real project that's going through many, many iterations, there'll be several that don't change the database at all. That's great, that's easy. But there will be migrations that do change the database, and mostly you're going to be adding things. You might add extra columns to a table, so extra attributes to the table, or properties to the object, if you like, as your iteration is using, as your application development is describing more of that object. That's very easy to do. You might add extra tables, you might add extra relationships. And sometimes you'll need to go back and change something you did before. Again, just as you would do in developing an application. Most of the code you write, if you're doing a good job, and most of the teams I've seen do, most of the code they write survives all the way through. Occasionally you have to go back, this is a bit more complicated. It would be better if we did that bit we did before a different way, so we have to rewrite a little bit. We shouldn't be afraid of doing that with the database or with the code, because it's still a hell of a lot more quicker than trying to guess what it's all going to be up front and getting it all wrong. We find out early and we go back and fix a previous iteration if we need to. For another thing that's a parallel with developing code is that if you're migrating data, as you will be after the first, the first few iterations, you'll probably run all your tests by loading the data in, applying stuff to it, and making sure the tests work. As time goes on, and especially once you've got a released version of the application and you're doing further iterations on it, then preserving that data is really, really important. And when you migrate it, you sometimes have to reorganize it a bit, like, well, as we were doing in the example there. So certainly when migrating data, we build tests to make sure that we haven't lost anything, duplicated anything, or come up with a structure that doesn't make sense. Usually it's losing things and duplicating things are the easiest things to get. Yeah, sure. Well, we use SQL, and there are, do you know, how many people know SQL actually?
I think a fair few.
So we use joins a lot, but there are some other commands that are set level things. A lot of people use union, but there's also intersect and either minus or except. They mean the same things, but different databases. Oracle says minus, Postgres says except. Except is the standard, I think. So it's like a Venn diagram, and you can say, the union is all of it. The difference is, one minus the other. Those are really, really useful for checking that you haven't lost things. So you can try queries on the new structure and compare it with an equivalent, but it will be different query on the other structure, and make sure you get the same numbers. That's, your test fails if you don't get the right numbers, but also you can check that you haven't scrambled the values either. So it's not that you always use those set level functions, but they are very useful in writing SQL tests for a database and comparing different versions and making sure that it's been transferred properly.
Yep. If you look in the scripts directory, there is, from memory, a migrations check.sql, which basically does exactly what Ron's describing. I've taken it out of the main iteration code just because we just don't have time to cover everything about this sort of stuff.
That's on, if I remember rightly, because this is quite small data set, it's about 1,000 rows, I think. It's very easy to just run a query and see if it looks right. But obviously, on the kind of scale that we're using in real applications, you can't do that. You get a lot of, I've met a lot of people on projects who will actually run, have a look at the first 6 rows and say, oh yeah, that looks fine. But if you've got 1 million rows, that's not going to cut it. You're very unlikely to find the problem in the first 6 rows. So that's when those kind of set level operations come into effect. There is a lot more detail on this in the book, and I'll tell you more about the book in a minute. That's about migrations and testing. And another thing that the old-style database designers will say is never change anything. If it ain't broke, don't fix it. Well, it might not be broke, but it might not be. You might have problems in there which are going to make future developments more difficult, or that's going to make it very inefficient, or make it less safe. So I would say if you spot a design improvement and refactor exactly as you would do with application code. I don't know why these two things parted so much, but you really can apply the same principles that you would apply to code to a very large extent with the database. And the other thing is storing all the migrations in a version control system. And I think, maybe you could show that thing running that you showed me at lunchtime. It just runs them one after the other, and because it's tested in the environment on this laptop, then it does, it does just tick through, and you can, you've got control of what the versions are, and you can't change things without it breaking the system. You find out if somebody's changed something outside the environment. Again, just like you would do with code.
Yeah. Can I add one story? I was actually working on a system, and we introduced Flyway, which is what we're using here to demo. And one of the other teams came across and said, your database migrations have stopped working. So I took a look at the error and said, no, our migrations are fine. Somebody's tinkered with the database. No one's touched the database. Went away for an hour. Basically said to the guy, no, go away and ask your team, see if anybody's changed anything in the database. About an hour later, he came back quite sheepish and said, yeah, someone did a manual change to the database, and Flyway just went bang, because suddenly your database is uncontrolled.
When you say it went bang, it gives you quite a friendly message that says, this is wrong, you've changed this.
A friendly bang.
Yeah, yeah.
So yes, it's very powerful to control the database structure. You cannot change a script once it's out there and in the wild. You must not. This is one of the things to think about using these techniques.
Yeah, and I think this is one thing that DBAs hate about moving out of their ivory tower and moving into the team where they belong. There are two things they hate. One is that they cannot use those management tools that the big vendors like to sell, that just let them go and change things through a GUI. Completely unrepeatable. They can't even do it themselves in development and test and production to do it the same way, because they're not running a script that's been tested, they're just changing stuff. Can't use that anymore. And the other thing is they have to work with the team and actually share their skills and share the other team's skills and understand what they're doing. But DBAs do have some very valuable skills, especially when you get big systems and you've got to tune them. But they just have to work with the development team, I think, and that's what I always try to do. So, what time do we finish? It's 20 past. I'll probably go through all of this.
It'll be nice to go through the example
on
the screen so I can show everyone what's happening inside. Okay. So this is quite
just to emphasize the point that you only build what you need for this iteration. And if you ain't going to need it, don't do it. And that's another thing that a separate DBA team will do. Oh, you'll probably need an index in this. Oh, you'll probably need some spare fields, because spare fields are really, really bad idea. Really bad idea. You add them when you need them. Don't clutter up your database with all kinds of stuff. There's a long story on cluttering up databases as well, which we could go into. And no database views, because views are designed, their selling point is that you can take incompatible versions of the database and the application and make your database look like what the application wants. They get really out of hand, because then the next time around they build more views on those views and more, and it gets less and less efficient and much more difficult to understand. So views are out. Don't ever use them. That usually upsets a few people. I'll skip this one and the next one, I think. Test-driven, well, we just talked a bit about testing, and SQL scripts are great for doing that, because SQL scripts are, well, they're non-procedural. You don't have if, then, else, and loops and stuff. So you're saying what to do, not how to do it. The database query optimizers these days, I mean, they've been doing it for 40 years. When they first came out, they were slow and clunky, and some queries would run fast and some slow. These days, they're really, really consistent. But those kind of set-level operations, and it's not just the three I mentioned, union, intersect, and accept. It's the fact that you're operating on sets of data and you're not just testing 6 sample rows. You're saying, do all of these rows, and all of these rows follow the rules that we expect them to when we put them together. And you can write one query that will tell you that. So SQL is a very powerful tool for writing tests. And there are various ways of automating and running them, some of which you'll see in a moment. This is the third example where we sorted out the boat thing, and that's different from the qualification in that well, I've made the assumption, which I would have checked with the users, of course, is a boat ever owned by more than one person? And the assumption I've made is no. So a person can own no boats. When I belonged to a sailing club, I didn't own one. I used to crew for someone else. Or they might own one, or they might own three, or who knows, lots. So that's the what has many thing. A member has many being 0 or more boats, and each boat's separate, and you can. It's much easier to query that than the structure over here, where you've got to look at 9 different fields. You've only got to look at 3 there. Okay, that's pretty much it. So I can leave it on that, and we can go back to whatever we can do on the exercises, and then hopefully have a bit of time for questions and to mention again my book.
Yes. This is turning into more of a talk than a
yeah,
workshop. I
do apologise. Which wasn't quite what we
apologise.
intended, but here we go.
But
Hopefully we can recover that a bit.
Before we go and wrap up, I just want to show you what's happening inside the database. Because we're having some technical issues around the laptops, feel free to take this away and play with it and get in touch with myself or Ron if you have any more problems. But I just want to show you what's happening inside. So if I just fire up my system, what I'm going to do, I'm going to mirror display so I can see what's going on. So if I just start that, I'm already running. So I've already got Postgres running in Docker. For those not familiar with Docker, this is just going into the container with a bash shell. And the reason why I want to do that, there's PSQL sitting in the container. PSQL is the command line for Postgres. All will become clear in just a moment. So, nothing up my sleeves, no relations. Basically, this is an empty database.
And relation is the jargon word for a table. I say don't use the word relation unless it's your auntie. It's a table.
And you'll see in the Git repository, there's iteration 0, iteration 1, iteration 2, and final. These are basically the steps that you would have gone through in the workshop. Try 0 first, then see if it matches the starting point of iteration 1. If it doesn't, then think about why it doesn't match. Same with going from 1 to 2. Start off with 1, move on. I think we break apart the member and the qualification in that step, and then match it against iteration 2 to see if it's got the same stuff in. And then finally, match it up with final, see if you've got the same sort of script, same structure. So you need to run the application purely because this is what does the update. Remember that main running flyway? That's what it's just done. So if I now look at the relations, at the tables in here, you can see it's created a bunch. But the point I want you to take away, you've got a flyway history. You've got a history schema. Actually, if I just expand that up. So what these frameworks do, they do this. This is the way Flyway does it. DB Unit does it a different way. Liquibase does it a different way, different name table, but this is essentially all they do. Version 1.0, your first script. 1.01, the second script, and so on and so on and so on. It's just incrementally adding to it. If it's run already, it'll just be ignored. If it doesn't match a checksum, it'll go bang. It will say, something's changed here. Are you sure this is the same database really? But effectively, what you're doing is version controlling a database in a version control system. Just Flyway specific note, you need 2 underscores to separate the version from the description. You need to start it with V, unless you tell Flyway otherwise. You can use an underscore instead of a dot. All on the Flyway webpage. I'm not going to tell you how to run Flyway, because it's only one of a number of frameworks. And also different technologies approach in a different way. Well, that's effectively what they're doing. And just for completeness, what we've got here then, first. And there's data. So it's already been migrated. And as you do this, you go further and further and further on. So any questions about what's happening inside? So what I propose we do is, it's 4:30. What I suggest we do is we'll take some questions. If you want to stay, once we're done, then we'll work with you to try and get this system running on your laptops. Obviously, there's been some difficulties, which I've actually jotted down a bunch of stuff to improve for next time we run it. And we'll take it from there.
Could I suggest you run the other 2 iterations so you can see what?
Oh, yeah, cool.
See what
just quickly.
we end up with, and you'll.
So that was
because
running.
it is. You know, once all these bits and pieces are working, it is very straightforward and controlled way to do those migrations.
So remember what I was saying about iteration 2. Right, let's just double check where we are. So we run iteration 1. That's supposed to be mirroring the screen. It lies. It lies like a cheap watch. So we've done iteration 1. 1s are in there. And I'm going to run iteration 2. So what we've got here are all the scripts for qualifications and things like that. I haven't touched anything else. I've just added the scripts. And again, I've run it on top of what's there. It's just added what's missing. And finally, just to wrap up, again, version 3. You've got 2 steps to migrate the boat. As you can see, Flyway is giving us a gentle warning. But it's still finished it.
Oh, why did we lose the screen?
Didn't touch anything, Gov. As I said, we've got version 3 in there. So that's basically pulled in all the changes that we've asked it to do. These changes aren't just from a clean Excel database, not Excel spreadsheet. These can be changing requirements. Yeah, we're a club, we've got a few members. Okay, let's do the database. Actually, these members have got a qualification. Okay, we're going to add a qualification. actually we need more than one qualification per member. Okay, we can start to join tables up. We can work out what the structure is. As we discover the class structure, we can reflect it in the database. Okay, all our members have bought boats apart from him. Change the requirements. It's just as valid using this approach with changing requirements, evolving requirements, as it is just saying, okay, we're doing a set of known data. I'm going to do this, I'm going to do this, then do this, then do this. So it's worth bearing in mind. Same techniques work. It's iterative database design, and it's version controlled. And that is all of the exercises. Like I said, if you look at what I've called final in the repository, you'll see all of this. And I have no idea what that's.
There we are.
Causing me trouble. That should be mirroring screens. It's refusing to. So just to wrap up, relational databases, yeah, they're great. No SQL databases, but you can't do that to it. More difficult, but it's horses for courses. Guess what relational databases are good at mapping? Relational data. It can be agile, it can be rigorous. We can treat it the same way we do our code, the same quality as we do our code. Like I said earlier about the frameworks, yeah, you might want to use a framework sometimes. I've never liked what the frameworks produce, personally. And just as an aside, no reason why a relational database can't be huge. How big's the marine database you were telling me about?
So, yeah, the picture on the cover, that's a picture of a system called AIS. Every ship in the world above a certain size has to have an AIS system, and that tracks the position of the boat wherever it is. Smaller boats can have it as well. A lot of sailing boats have it now as well. And very useful, as I found, sailing into the Solent in the middle of the night, and there's a tanker. Is it moving? We could go and look it up and say, no, it's been there 3 days, and it's not going to leave until Friday, whatever. They do 500 million ship movements a day. I've forgotten the number of users. The number of users is in the millions per month.
Quite a few.
Yeah. And it runs on a Postgres database. And you can look it up, and they tell you what things they've done to the design. And they've done very little, really, beyond standard Postgres to actually make that perform really well. But you can look it up. You can look up a particular area and say, show me the boats. And the screen comes back really fast with all the boats where they are, and you click on the boat, it tells you what it is, where it's come from, where it's going, whether it's underway or whether it's moored, whatever. And that's running on Postgres. Another one that runs Postgres is Skype, and there's some information on how they've implemented that as well. And Skype is really, really huge, and they have had to do some things beyond what the standard database design that you would use for a normal application with a few million rows. But they started off from a pretty standard thing. So these databases can be really big and still be really fast. And of course, when we said agile and rigorous, those two together it can be. It's not either or, you can do both. That's what we're talking about. If you're interested in, the AI system, if you take my card, you'll find there's a website link on the back, and it tells you all about it, and where the links to the actual owners of the system are, and they tell you how they do it. It's interesting. Yeah.
Yeah, so with that, shall we open the floor to questions, including how do I get this running on my laptop?
I think in the AIS system, it only records the boats that have the system, which is a bit dodgy for the small boat. But in the general case, like in the membership database with members of the database may or may not own a boat. So if they don't, the member exists, and there is no link. Well, the link would come from the boat that says, I am owned by somebody. Well, there won't be a link to that person. So that person will not, if you try and join the record for that person with the boat table, you'll get the person data back, but not the boat, because there isn't one. So whether you make, whether there are missing rows, because that thing isn't represented in the real world, or missing values in a table. Great example, I worked on a car insurance system, and they had a date cancelled for the policy. Well, you want most of those dates to be null. You know, in practice, you'd have less than 10% of the policies that you knew about cancelled. You still had to record information about them because people could make a claim 7 years later, up to 7 years later, and they did. But you'd have this cancelled date, and in most cases it would be null. So nulls, you know, you do need them sometimes, and there's a perfectly good reason to use them. But when it's something that can't be null, like in that insurance system, a policy number had to have a policy holder. You couldn't have the policy holder being null because you have to know who it is that they're insuring. And yeah, so nulls are very useful, a bit confusing, and often overused. There's a whole chapter on nulls in the book.
Yeah, and don't use them in your code.
Sorry?
Don't use them in your code. Leave it to the database.
Yeah.
Nulls are evil.
Yeah. Yes?
When you have migrated the data, like in the examples, it was the member qualifications, would you then drop the original columns from the first?
Well, lovely question.
We'd actually...
I asked that.
It depends on the kind of system you're doing. So at the moment, I'm working on a data warehouse system for a charity. And they've got a horrible system for keeping track of their donors. It's a very old system, very complex. And we copy all that data into a staging area in the data warehouse. And then in a separate area, in a separate database, we keep the cleaned up version. And then in another separate area, we keep tables that they run the reports from. If you're running an application that's a transactional type application, it's really important to get rid of the intermediate stuff and old stuff. You really have to be quite rigorous about doing that. I worked for a Turkish bank, and they were buying a new machine to run their transactional databases, and it was going to cost them $2 million, and the only reason they had to buy it was because they had all these hundreds and hundreds, thousands of tables in the database, and they didn't know whether they could get rid of them or not because they didn't know who was using them. So the time to get rid of them is when you said, okay, I've migrated that table into the new one, I've tested it, we've run it live for a month, kill the old one. Really brutally get rid of the old stuff.
Yeah, the reason why I said I asked that was I did my solution, Ron gave his SQL script solutions, and I looked at them, Ron had copied it into a separate table, I'd actually modified the existing table. So I asked exactly the same question, well, what do you do that way? Oh, yeah.
So, yeah, I mean, they were both valid. They're both valid solutions, and on this size of database, it doesn't matter. The problem with, you can use an alter table command to change the columns in a table, to add columns to it. If you do that on big tables that are used with high volume transactions, they get very inefficient. Because if you make a row longer, it might not fit in the block that it was in, and so it has to have a chained block and in the index as well. And it just it's like a fragmented disk. So it's much better to have a clean one for an operational system and to get rid of the old junk. And you have to be quite brave to do it, but you have to do it. Otherwise, it's going to cost you a lot more. I mean, you've probably got a offline backup somewhere, but not in your live database. You don't want all that rubbish.
Yep. Got another question here.
So every time you stand up a database or create an instance of a database, you're running every single script on top of each other separately. Is that correct?
Yeah.
Yes. So they're all in the version control system. You can, if you do have to recreate one, I had to do one, this company that doesn't exist anymore, Netezza. We run it for 5 years in the insurance company and it was full, so we had to get a bigger one. And we actually worked out the easiest way to recreate the databases was to run just the ones that defined the tables, to run all those scripts from the version control system, just one after the other, because creating tables is really quick. And then we copied over the data, the live data. So we made sure that we'd got to the same place. We could have taken the definitions out of the existing database and put them into the new one. But it was actually easier to just run through our table definition scripts.
Yeah.
I thought foray actually detected which changes had already been run. Certainly Liquidbase does.
Yeah.
So you don't actually run them all, but it processes it and decides.
Yeah, yeah. Yeah, so the only time you do that is if you were...
But you can also take a baseline.
Yeah.
You can baseline.
So you would only do that if you were starting from scratch again, which is
Yeah.
the situation I was talking about, yeah.
It-
But normally, yeah, as you said, exactly what you said.
So for instance, if you're, every time you want to run your integration test, whenever you tear down your environment, create a new one from scratch, using flyway view of the database, it will eventually go
Yeah.
Yeah, go through all that.
mention baseline there.
Yeah.
Because if you have lots of expensive migrations and
Yeah.
long history of massive database, it
Yeah.
becomes a long process to actually repeat all of those steps.
Yeah.
Yeah.
From memory, baselining in Flyway says start from version this.
Yeah.
Pretend it's this version. You go ding, 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 ding,
Yeah.
all the way through. And basically, using the table I showed you to tell it what's been run before and what to ignore.
Yeah. So when I was working on a project, probably the first Agile one I did. So in development, initially we'd rebuild everything. Then when we got a lot of data, we just run the final scripts in development, then go back to, it didn't work, so we go back, fix the problems, run it forwards again. When that was working, move it to test. And when it got to live, we'd be very confident, and then we could just run the last bit of the migration, because you don't want to be pushing data about all over the place when you've got huge production volumes. So you do just do the last bits then. So it depends on where you are in the cycle and what sort of problem you're trying to solve, but you could do either way.
Can I just add one thing to it related to that, is that if you make a mistake, you can't go back and just change the script. You've got to correct the mistake in sequence at the next thing you check in. So that's just a gotcha to watch out for.
Well,
I've been bitten by
Yeah,
it.
it's like it's like an accounting system. You shouldn't go back and change a transaction. In your bank account, you wouldn't like it if they went back and changed something that was wrong. They should apply a new transaction which corrects it, so that the auditors can see that was a mistake. Here's the correction. Here's who did it. Here's why they did it, and then you go forwards again.
Yeah.
Rather than just patching it and losing all your audit trail.
Anyway, I think that about wraps it up, unless there's any more questions.
As you can see, I've got a few books here. If anyone's interested, they're, if you buy it here, it's 12 quid. If you buy it list price, it's 20. If you buy it from Blackwell's online, it's about £15.60, I think. But if anyone wants one, please come and see me. And certainly take a card, because there's a website that has all the data and the scripts and everything from the book, plus some other tools that I have found useful. So take a card anyway, and if you'd like a book, I'd be delighted to sell you one.
Yeah. I'm afraid I'm not an author. I'm not intelligent enough. But that's me, Thirsty Bear Software. It just leaves me to wrap up and say thank you very much for your patience.
Thank you. Yeah.
It was an interesting layout, interesting workshop, quote unquote. Feel free to come and have a chat. if you've got any suggestions about how we can improve it. We know about the layout because we were expecting tables. Thank you very much for your time.
And I think